Welcome to episode 18 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so scientifically important. So let's run the random number generator. The coordinates for this episode are 3 hours, 8 minutes, 38.9 seconds right ascension, and plus 13 degrees, 9 minutes, 26 seconds declination. This points to an object in the constellation Aries, that's Aries from the zodiac, called GRB 100-206A. The GRB in the name for this object stands for gamma ray burst. Gamma ray bursts are sources in the sky that briefly produce extremely huge amounts of gamma radiation over a single period of time that could be as short as a few milliseconds or as long as a few minutes. They were discovered in the late 1960s by American satellites designed to look for gamma radiation from nuclear bombs on Earth. It wasn't until 1997, however, that these were identified as objects outside the Milky Way galaxy. Gamma ray bursts are thought to be formed multiple ways. One of the phenomena that could form gamma ray bursts are the mergers of either two neutron stars or two black holes. These bursts are expected to be shorter than 2 seconds. Bursts longer than 2 seconds are thought to form primarily from supernovae. GRB 100-206A was detected at 1:30 p.m. Universal Time on February 6, 2011 by the Swift and Fermi satellites, which were designed specifically for detecting gamma ray bursts. The total length of the gamma ray burst was 0.2 seconds, which places it into the short burst category. After its detection, a series of observatories around the world observed the burst in the near-infrared and visible parts of the electromagnetic spectrum to try to find the afterglow that should be produced by the burst at these wavelengths. It would be fun to name all of the observatories that looked at this object, but then I don't think people would want to listen to me read a list of observatories for several minutes. Besides this, none of the observatories could find the afterglow, which was a little bit of a letdown. Despite this, a couple of the larger telescopes that tried to detect the afterglow and failed were actually able to detect a galaxy near the position of the gamma ray burst that is most likely to be the host of the gamma ray burst. And the host galaxy turned out to be one of the most interesting things about this gamma ray burst. Researchers also dug up archival mid-infrared, near-infrared, and visible light data, and managed to detect the host galaxy in those data as well. The galaxy appears to be a disk-like galaxy, which would mean that it's probably a spiral galaxy, and the galaxy is at a distance where we are seeing a light emitted when the universe was 4.5 billion years younger. Although for complicated reasons, that does not exactly equate to a distance of 4.5 billion light-years. What is really unusual, though, is that the host galaxy is a luminous infrared galaxy. These types of galaxies produce infrared emission that is equivalent to somewhere between 100 billion and 1 trillion times the total amount of energy emitted by the Sun. The host galaxy for GRB 100-206A, like other luminous infrared galaxies, is forming stars at a very rapid pace. Stars are forming about 10 times faster in the host of GRB 100-206A than they are forming in the Milky Way galaxy. The regions where stars form are surrounded by clouds of interstellar gas and dust, and the dust absorbs the ultraviolet and visible light from the stars in these regions and re-radiates the energy as infrared light, which is why the infrared brightness is so high. For comparison, most other short gamma ray bursts are found in galaxies with relatively wimpy star formation rates. The host galaxy also has a rather unusually high amount of elements heavier than hydrogen and helium, which implies that for a very long time the galaxy has been forming a lot of stars that can synthesize these elements. Nonetheless, Astronomers expect that the gamma ray burst may not be associated with the younger stars in its host galaxy. Instead, the burst may have actually formed from two merging neutron stars or two merging black holes that were intermixed in the very old stars on the outskirts of the galaxy. A few more gamma ray bursts have similar host galaxies, but it's still rare to find a short gamma ray burst like GRB 100-206A that is associated with a galaxy where stars are forming at such a rapid rate. It just demonstrates that we shouldn't make too many assumptions about any specific type of astronomical phenomena and where we're going to find it. The position on the Earth's surface corresponding to the location of GRB 100-206A in the sky is in the Gulf of Aden, about 46 kilometers off the coast of Yemen. The Gulf of Aden is one of two bodies of water that separates the Arabian Peninsula from Africa. It formed from a mid-oceanic ridge where the African and Arabian plates are separating from each other. The Gulf also connects the Red Sea and the Suez Canal to the Indian Ocean, so it's a major shipping route. However, it just doesn't seem to get the same press coverage that the other nearby bodies of water seem to get, such as the Red Sea and the Persian Gulf. The website for this podcast is www.randomastronomicalobject.com, which you can visit to download episodes of the show, read information about the astronomical objects, view images of those objects, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The sound effects are from the Free Sounds Project at www.freesounds.org. Thanks for listening.